Okay, welcome back, everyone. Hope you got some time to get caffeined up. Next up, we have Wojciech Gawroński, also known as AWS Maniac, who is a co-founder and cloud architect at Pattern Match. And today he'll be sharing his passion for everything AWS and give us a honest review of Amazon SageMaker, including when to use it and when to avoid it for machine learning lifecycle management. So this will be a live talk, and Wojciech will be available at the end to answer your questions. So please drop them in the Q&A tab in the right down side as he follows along. And welcome, Wojciech. I'll let you take it from here.
Thank you very much, Marta. So let me share my screen and we are ready to go. Once again, good morning, everybody. Welcome to the talk about the truth about Amazon SageMaker. Like in the Matrix, I can offer you only the truth, no matter how it will be. And this is pretty interesting topic because machine learning and artificial intelligence are having a lot of buzz, a lot of interest nowadays. From the business perspective, this is the place when most businesses build the competitive advantage and leverages. And it's great to observe that many vendors, including AWS, Amazon Web Services, are covering us in that space. But even being highly passionate about the cloud, we should be aware that those solutions have some deficiencies and drawbacks. And that's why this talk includes good, bad, and ugly parts of the aforementioned service available in the AWS portfolio. A quick introduction about me. Besides what Marta said, I'm also an AWS Community Builder member program. I'm also 8 times AWS certified, and I'm running a company that specializes in cloud computing. I'm one of the co-founders. We're specializing in cloud native software development, in particular with AWS as well. If you would like to contact me, here's my email. It will be available also at the end on the slides. To complete everything, here are the links and websites when we are sharing our knowledge, including social media and our blogs. But enough of the shameless plug. Let's talk about today's agenda. So first things first, I will try to sustain your attention as much as I can. So we will start with the very quick pitch about SageMaker, what it is. Then we will go through the demo, and later we will talk about these pros and cons that I gathered about from our projects. Everything that I will talk about, everything is collected as a collective wisdom from our company and real world projects that we developed there. So let's start with the sales pitch. If you heard about SageMaker, just type heard in the chat. If you use it, please type use. My goal is to explain, like I'm 5, what the SageMaker is if someone didn't heard about it. But if you already used it or heard, it will be good to know about the audience and how experienced you are. We'll start with the marketing tagline. So basically, what you see on the slide is it's pure marketing. You have logo in the upper right corner. There is a whole machine learning software development lifecycle available at the bottom, and supposedly SageMaker covers everything, the whole spectrum that client needs in this machine learning development lifecycle, starting from preparation and data preparation. That includes also the manual work that requires human workforce, through building, training, tuning those models, deploying them, managing, observe, operate. Everything is covered under the name of the Amazon SageMaker. However, it's not an open source technology, so AWS documents most of the stuff. It builds on top of open source because we are using open source frameworks like TensorFlow, Keras. We will talk about it later. But still, there are some places when they are not exposing everything, and this is often an educated guess, and I will mark this as a gray area. Last but not least, you may be sometimes buffed by the difference between Amazon AWS prefix. Long story short, if something is independent from the other AWS services, it often has the appellative Amazon. If something is deep dive into roots, something has the prefix AWS. So let's talk about the SageMaker in practice. I will show you the demo first, and then we will go through the available elements. So first things first, when you are logging to the console and you will enter the SageMaker service, you will see that you have plenty of services on the left side in the sidebar. Starting from the data preparation and data management, which is called ground truth, when you can have labeling jobs, including manual workforce. You have also notebook management for exploration and data science, which includes also managing the Git repositories for data scientists. Then you have the old processing elements that allows you to operate everything in a fully managed way. Later on, you have training, which is basically both training jobs, tuning, automated hyperparameter tuning jobs as well. Everything that is related to building those models. When you have your trained model, you can actually deploy it, and it is hidden inside the inference under the endpoints tab here. So you can actually go with your existing model or trained model on SageMaker, deploy it on the endpoint, and then this endpoint is available as a REST API, which you can call and ask for the inference results. Last two elements are related with the both IoT management, which is pretty useful if you are managing the fleet of the devices. The Edge Manager is pretty interesting service in itself, and augmented AI, which is helping the managing the human workflows and manual workflows. Last but not least, there is AWS Marketplace, when other vendors, not only AWS, but all the vendors are providing their models, their additional tools, services on top of the SageMaker. The most important thing for us is the exploration, because in most cases everything starts there. I will go to the notebook instances, and I already have one notebook running, which is focusing on the computer vision model, which is facial expression detection. I already prepared something for you and tested it, so I have everything available in the Jupyter notebooks, which you should be pretty familiar with if you are working with the data scientist. But for those of you who haven't worked with Jupyter, it's basically a source code with markdown annotations that you can interleave and work with. I would like to present you the emotions detector, which is basically a computer vision model that detects emotions from the human faces. We are using two data sets from available publicly, which is called facial emotions recognition from 2013, and FAIR Plus, which is the more modern data set. This is basically a set of extracted images from the websites and manually labeled by the peer reviewers. We will use TensorFlow with Keras, and we will build a VGG13 convoluted network inside. The most important stuff for you, if you haven't worked with the SageMaker, is that it changes a little bit the work regarding the exploration, but it doesn't change everything you know about TensorFlow, about frameworks, about machine learning itself, because it builds on top of those open source solutions, so you don't have to learn anything new. The one thing that you need to be aware is basically the way how to interact with SageMaker API. And this is the setup that you need to establish a session which allows you to call the APIs on your behalf with the SageMaker. Then we are including standard libraries from the Python. People that are familiar with data science will see familiar modules available there. And later on, we will basically have the data preparation step. I will take the CSV files, extract the images, and present them as a result here. So basically, we can extract every single image. This is interactive. I can evaluate this cell. Obviously, if I will basically read the data files from the S3 again. But if I will do it, you will see that after a moment, the new image will appear, and then later on I will be able to see what was the label associated by the human reviewer with this particular image. So you can see that this is indeed a surprise image. Later on, we need to prepare a training script, which is pretty much as we will do with the regular machine learning, for example, on localhost. This is a regular Python script that employs the TensorFlow and Keras. Here's the network structure, compilation fit. The only difference that you will need to use in order to use SageMaker, the only difference that you need to accomplish is to properly use the provided arguments, because SageMaker as a service calls your script and passes the data into your script in a proper format. So you need to be ready to actually do that. And last but not least, the only thing that you need to adjust is to how the model will be bundled, because you need to save it in the proper both path and also in the proper naming convention. But those are two differences that you need to accomplish in order to use the SageMaker. Then having the script, you can actually call the API with the SageMaker SDK and start the training job. I already did the training job because it takes almost 20 minutes. Here you have the TensorFlow output, which supposedly trains everything correctly. Last but not least, you have the network structure and information about the trained epochs, including the accuracy loss and validation process. At the end, you have the information how much billable seconds you actually pay for this training, and this is an information that you can directly transfer to the cost of the training phase. If you have already your model available, it means that you can deploy it with the endpoint, and this endpoint will be available as a REST API that you can call, also with the help of the SageMaker SDK. And then by calling this API, you can actually receive the results. So I already prepared you an interactive test. You can see that this is the camera available in the Jupyter. I already snapped my photo here. I need to pre-process it in order to provide it in the same way as the data that was used for training. So I need to extract my face and convert it to grayscale. This looks pretty creepy, but at least it's close to the final image that we use for training. If I will evaluate this predictor, you can see that it returns that with the 89%, this is the happiness emotion detected from the image. And we can do the sanity checks. For example, we can randomize the training or validation data sets and see what was the detected label. So in this old data set, we have the surprise label. In the new data set, we have surprise label. And the detected model returned also the surprise label. We can work with the all available knowledge and skills that we have already, including, for example, delivering confusion metrics or analyzing the ROC curves and so on and so on. Everything else works as in the old, good old known frameworks. And if you have already built in TensorFlow knowledge, Keras knowledge, PyTorch knowledge, everything else is applicable here as well. So enough regarding the demo. To give you just a summary, the whole demo that I will present to you, which takes like 2-3 hours, costs like $3-4, so it's not a lot. So everything else it's covered by the it's pretty cheap in that regards, that if you are playing with it, it's not as expensive as it may look in the first place. Regarding the rest of the talk and what the Amazon SageMaker really is, if we have the baseline and I show you the demo, you already have some notion what this service provides you. But first things first, as I said, and you saw it in the demo, this is a set of services. I call it an umbrella service because in most cases, we are actually dealing with multiple different services inside one name which is Amazon SageMaker. And this is the pretty important distinction and pretty important knowledge to have. Those services in most cases are independent from each other. So it doesn't mean that you have to use training and then deploy your model because it requires you to train it on SageMaker. In many cases, if you have already an existing model that it's prepared in a proper way, you can actually leverage that model and deploy it on SageMaker without using the training phase. And in the opposite way as well. So you can only train your models on SageMaker, but deploy them somewhere else because you can extract them and actually deploy them with the TF serving or something different. The most important thing that I would like to mention is that this is one of the fastest growing services available in the AWS portfolio. Since the 2017, when the SageMaker was released, they released almost 200 updates. So it takes that for the 3.5 years, they released 57 updates per year, which is a tremendous pace in terms of the availability and the growth of this platform. And it's growing and growing because, for example, if you will look on the all 4 phases that I shown you on the diagram, it has multiple different services. For the data preparation phase, you have all those 5 services that are available on the slide. There is also Amazon SageMaker Studio that actually wraps everything and provides you an IDE, a tool that gathers everything under one user interface, which is pretty handy for the data scientists especially. In the data preparation phase, you have the data sets modeling and labeling services. You have the fully managed processing. You have also feature storage and many interesting stuff. I would like to emphasize that this feature storage is the new thing, but it's also a game changer in many cases, because in large organization, feature engineering is pretty expensive. And also, if you've done it properly, you would like to actually, those features should be available for other teams that are working with this data. So it's actually great to have such thing like feature store in order to expand and work correctly with many services. In the build phase, SageMaker portfolio is also very comprehensive. I show you the notebooks. You have a lot of algorithms that are built in, but you can also bring your own algorithms, customize your Docker images, and work with anything that you will come to your mind. You can also develop everything locally, and you have helpful services like Autopilot and Jumpstart for delivering value as quickly as possible. The very interesting is the Autopilot, because it allows you to create a machine learning model in a fully automated way without the exploration and without the manual data science work. So sometimes, in some cases, this may be a great starting point and good start for your models. In the training and tuning phase, we are also covered fully. So outside of training capabilities that I show you in the demo, you have experiments management, model tunings, managed spot training, distributed training, and also debugging. And this is pretty interesting because you can debug your models during the training phases, but also in the deployment phases and how they operate in production as well. The debugging is also pretty comprehensive. You can see the tips and informations about GPU utilization, maybe some issues that will be found proactively. Additionally, you can see how much time it's spent in different phases of your training process and how it utilizes the hardware, and that will allow you also properly assign capacity during the training and tuning phase. Last but not least, deployment and management. This is pretty interesting as well, because it covers everything, including integration with Kubeflow, having the fully managed endpoints that allow you to deploy the models, allows you to monitor those models in operation, in production. It has also the support for IoT devices and then fleets of those devices, and also Amazon SageMaker pipelines, which is pretty new thing, but it's really awesome because it allows you to create and MLOps pipelines for your models on top of the Amazon SageMaker. And SageMaker pipelines are pretty deeply integrated with the Kubeflow, with Apache Airflow, so we can actually use them pretty well with the not only with the AWS portfolio, but everything that you are using currently in the organization. So that was the more or less a complete list of services under the name Amazon SageMaker, but that's not enough because there is also a few of related services available that are related to machine learning. I said already about Marketplace, when other vendors providing models and algorithms, there's dedicated chips like AWS Inferentia and AWS Trainium for both inference and training phases. There is the Elastic Inference Accelerator for managing the and helping to optimize the costs when you are training models that are not fully utilizing the GPUs, but they are too hard for the CPUs. And there is also a Neuron SDK, which allows you to optimize your models on top of the new chips like Inferentia and Trainium. So there's a lot of interesting services available there. But I would like to focus on, in this phase of the presentation, on the best practices and pitfalls, because this is the place when I think the excitement meets the reality in so many cases. Start with the first pitfall, the truly supported libraries. On the screenshot, you can see that there is a plethora of available frameworks that are fully supported by the Amazon SageMaker, and that's partially true because in many cases you can use those pretty well. But the truth is that even that in some places you will find the information that all of the frameworks are supported, not all of them are equally treated. In my opinion, the best documentation and support is for the TensorFlow with Keras, PyTorch, and Apache MXNet. Rest is actually, you are on your own, basically. It's not impossible. So there's you can use Gluon, you can use ONNX, and so on, but you are on your own in most cases because documentation and examples are lacking in those spaces. You may say, okay, what about the languages? It's actually interesting because it's much better than the previous site. I think that obviously the Python is the best supported language, but there is a plethora of examples for Java, for Scala, for R, and even there are examples for such not unpopular choices like Julia, for example. So this is pretty good and pretty well supported thing, and that's actually great. Pitfall number 2, and this is actually pretty interesting and very important. Most of you know that inbound traffic on AWS is free, and in most cases that's true. However, in the fully managed services, you need to be careful about that. And this is the case for Amazon SageMaker, because if you will deploy your models on the endpoints, those endpoints are paid per gigabyte you will send to the endpoint. And for the text models or for the smaller models, when you are sending small amounts of data, that's not a big deal. But for the computer vision models, for the video processing models, those can be pretty high, those prices. So this is pretty interesting. And also, in many cases, not many people are actually not realizing that we are paying for the traffic twice in this case. How it happened? Well, basically, if you will deploy your models in the SageMaker, you are deploying them inside the Amazon SageMaker AWS account, which means that your app will connect to this model through some, in most cases from the private subnets, through some intermediary like NAT gateway. And you will pay twice for the traffic, because you will pay first for the NAT gateway, and then you will pay for the model endpoint. You can actually lower those quotes by leveraging VPC endpoints. And this is pretty important thing that you should go and do from the day zero. You should leverage VPC endpoints. On the slide, you can see that there is the endpoint SageMaker runtime. You can actually create this endpoint inside your private network, connect it properly, and then having this endpoint, you can save from 4 times less to 12 times less when it comes to the data, inbound data price costs. And that's the difference on the diagram. So having this endpoint available in your account and connected it directly with the AWS account, you are actually going not through the public internet, but directly to the VPC of the Amazon SageMaker AWS account. So you can actually save some money, and also it's much more secure because you are not leaving the AWS infrastructure in this case. So this is pretty important, not only from the cost perspective, but also from the security perspective. Pitfall number 3, and you may think that on AWS all regions are equal and unlimited, and in most cases for the US this is pretty true. However, there are some places, especially in Europe, when those limits are pretty low at the beginning, and if you would like to deploy not so huge infrastructure for the machine learning, but still a sizable one, you will basically hit those limits very, very hard. And the problem with those limits is that those limits are manually reviewed by the customer service. So you need to do it proactively in order to deliver everything on top of the deadline, because the round trip may kill the time. In some cases, we spent like a week waiting for raising the limits in the Ireland because they need to be reviewed with the team, reviewed with the infra team about the capacity. So if you have higher tiers when it comes to the support, you can reach to the technical account manager and escalate this properly. But other than that, you will need to wait to raise those limits proactively. So remember to actually do it if you are dealing with such regions, especially in Europe. US regions are treated a little bit more openly when it comes to the limits, at least when it comes to the SageMaker, in my opinion. Pitfall number 4. I said already that you can deploy those models on top of the Amazon SageMaker endpoints, and this is a pretty great service. It's fully managed. You don't have to worry about anything. You will basically get your model and deploy it somewhere, and API is available for you. However, there are some limitations that you need to be aware of this solution. First things first, the payload size limit. It's supposedly 6 megabytes, but the truth is that you are sending UTF-8, so you are slashing this by 2. And there is also additional HTTP headers and other elements that combined together gives you like 1.5, 2 megabytes of data that you can send to the endpoint. And this is pretty constraining if you are dealing with computer vision models or bigger NLP models, because you need to send more and you can't. Another thing is that this API for the endpoints uses HTTP 1.1 only. So there is no TCP, there is no gRPC available, at least over TCP. There is no HTTP 2. This can be constraining in terms of latency and in terms of real-time inference for example, video processing. You need to be remember about this. You may see that there are Docker containers, so you can actually have something on top of that Docker containers. But the truth is that, unfortunately, Endpoints API does not support anything else over the other than HTTP. Additionally, there's one problem in the endpoints that it's pretty painful. There's no way to leverage EC2 spot instances to save some money. There's also no way to leverage EC2 reserved instances there, but there are some hopes. We will talk about them later. But those two things are actually excluded from the endpoints. In order to save money, you can actually use Amazon Elastic Inference. Instead of having the beefy GPU-based instances, you can actually have CPU-based instances with the Elastic Inference. For some models, it works perfectly fine, and you can cut down the inference costs. Or you can actually have multi-model endpoints to amortize the cost of the both instances. However, not for the GPU and not for the Elastic Inference. So this is another pitfall, in my opinion. So if you have models that are available over CPU when it comes to the inference, then multi-modal endpoints can save some money. Otherwise, you are basically on your own. And there's all additional stuff which is different and confusing. Multi-modal endpoints are different from the multi-container endpoints, but still, those multi-container endpoints are limited to the CPUs. So you cannot actually have multiple containers on top of the machine that is having a one GPU. Pitfall number 5. So if you have an existing model, they will be compatible, right? In most cases, yes, but the devil is in the details. Sometimes manual conversion of your scripts may be required. As I said, at least some adjustments when it comes to passing parameters and similar stuff. The training script can be different, and also it will require you to slightly different environment variables management. So if you are doing something not common when it comes to the environment variables or parameters of your models, you may be forced to actually adjust that. Existing models in a well-defined format will work perfectly. We used YOLO version 3, YOLO version 4, so it's worked pretty well without any changes. But yeah, your mileage may vary. It depends, unfortunately, on the model. Luckily, you can use Docker containers with SageMaker, so any model, anything can be deployed there. And if you already have some Docker containers and your models and training instances are Dockerized, you have this for free and you will be able to use it. Pitfall number 6. AWS has a lot of services. Amazon SageMaker integrates with most of them pretty well. Here's on the slide, you can see the list: Athena, Aurora, a lot of databases, QuickSight, IP Gateway. Those are basically services that are directly using the SageMaker models and SageMaker endpoints. However, in some cases, you need to be aware of the constraints. When it comes to the API Gateway, which is the most popular one, I guess, please pay attention how you connect the API Gateway, because you should always connect it directly with SageMaker endpoints, and you shouldn't do it through the Lambda, because it actually kills your ability to send bigger payloads and also hits you hard when it comes to the execution time. The one thing that you need to be aware of this is also the execution time limit. If your model responds for more than 30 seconds, I think the API Gateway integration will be problematic, because API Gateway has a strict limit for the time execution of 29 seconds. So you won't be able to actually see any response because it's too slow for the model, and the inference is too slow for the API Gateway to answer. So keep that in mind and be aware that there's a limit of this. Pitfall number 7. We have fully managed services, so we don't have to care about anything. In most cases, yes, but again, the devil is in the details. For example, you have the list of errors available in the documentation that are related with elastic inference. And this can be pretty scary if you will face those errors for the first time, but you need to be aware of that and handle it properly. For example, if you are hitting an API and see an unfamiliar error, you need to react properly and be fully aware of that. In most cases, Amazon CloudWatch is your friend. There is also SageMaker Model Monitor and SageMaker Debugger. All those things are pretty handy when it comes to debugging and investigating what happens on the production. In CloudWatch, there are some limitations. I don't know why at the moment, but there is no way to actually see metrics for the elastic inference accelerator added to the SageMaker endpoint. This is pretty sad. CloudTrade does not track invoke endpoint API calls. This is pretty sad as well. However, there is a way called custom attributes when you can actually track those invoke endpoint API calls, and this is pretty handy if you will need to nail down this particular API calls that causes trouble. When it comes to the saving and cost efficiency, there's one best practice that is pretty new. In April 2021, they announced that SageMaker has EC2 savings plans. And finally, you can actually buy some reserved capacity upfront, paying for 1 or 3 years for even GPU very beefy heavy instances, and you can save from 20% to 54% in comparison to on-demand rate, which is a lot when it comes to the money. Unfortunately, there is no way to pay upfront for elastic inference for now, but I think it's a matter of time that it will be introduced as well. So regarding cost efficiency, if you have models that will be running for 1 year and you know that you will need this many capacity, make sure that you are actually investigating savings plans, because they may save you a lot of money. Another good practice, in my opinion, is to use the SageMaker Studio, especially if you have great and big data science teams. It allows you to connect with the single sign-on, set the proper IAM permissions, integrate with the feature store, handle limits properly, and quotas for the data science teams. So this is a single pane of glass for the whole SageMaker infrastructure and SageMaker models, which is handy for admins and also data science teams. And also, it integrates pretty well with SageMaker Debugger, Studio Notebooks, and many other things, which is the very, very handy thing. Definitely worth checking and trying. Another good practice, in my opinion, is to leverage the SageMaker pipelines. This is a new service, one of the new ones. It allows you to set up the MLOps pipelines pretty well. If you would like to have very customizable pipelines that are, and you cannot do this with SageMaker pipelines, there is alternative available on the AWS called AWS Step Functions Data Science SDK. Those two things are pretty handy as well. But in most cases, SageMaker pipelines should be the default way to go, because it's handy and it's fully managed. Another best practice, in the SageMaker endpoints, you have ability to do A/B testing with variants, and this is very handy for experiments, for deploying new models, for validating the quality of those models. This is very, very interesting stuff, and I would like to emphasize that this is one of the best things available with the SageMaker endpoints if you are dealing with the production models that are used in your organization. And when it comes to the capacity management, there's a great talk from the AWS reInvent 2020, how to choose the right instance type for the ML inference. This is available as a link in the slides, but also you can have the glimpse on the slide, which is how to choose proper model depending on your requirements regarding throughput, regarding latency, framework support, and so on and so on. The TLDR version is that GPU models, GPU instances are for models that are large, focused on deep learning. You have large batch sizes and high demand. CPU is for small models, well-known and traditional ones, because it will work properly. And elastic inference acceleration is for the mid-size models when the CPU is too small and slow, basically, and GPU seems an overkill. So you have lower throughput, and you can deal with slightly higher latency than usual. And for the well-known models like YOLO, OpenPose, BERT, and so on, you can actually leverage the AWS Inferentia machines and use the inference with the help of the Neuron SDK, because those models are actually optimized on top of that. And last but not least, SageMaker constantly evolves. One of the newest things available is the very tight integration with the Hugging Face. For those of you who haven't heard about Hugging Face, it's basically a GitHub for NLP models, so natural language processing. It offers a plethora of various models available for the language processing, text classification, including BERT, GPT, and so on. So you can actually integrate it directly with the SageMaker and deploy those models without training directly from a Hugging Face. That's very convenient. You can also train your own models with the help of the Hugging Face transformers, and so on and so on. Huge thing and very, very interesting. To sum up everything that I prepared for you, I know that there's a lot of useful knowledge and there's a lot of to process as well. So allow me to recap this properly. When it comes to recommendations, I would go with recommending the SageMaker Studio and pipelines. Learn about your models, use cases, and endpoints limitations. Then stick to the well-supported libraries and languages if you can. Raise the limits proactively. configure the VPC endpoints from day one, and be sure that if you have existing models, plan a short research and development work that will be required to actually adjust your models. And this will be pretty handy to incorporate it since the beginning. You should use Amazon SageMaker if you are developing models from scratch and you can actually expose them through the HTTP API. You are using well-known models without modification or with small modifications, and you have researched the gains and improvements that available in the SageMaker portfolio are available for you, and they are worth it. This is the when to use actually SageMaker. Those 3 points are pretty crucial. When you should avoid a SageMaker, in my opinion, avoid it only when the SageMaker endpoints are too constrained for you. If your models require low latency requirements, or HTTP is an overkill, or if you need to leverage a pool of existing reserved instances, this is also not a good way to utilize this. And you have requirements higher than the payload or execution time constraints, this will be also pretty painful. Remember that skipping the endpoints, this allows you to use certain services later. I mean, for example, debugger or the model monitor. But you can actually use everything up to the point of training and tuning, and then deploy this model somewhere else. But training and tuning can be done with SageMaker without any problems. So this is also pretty handy. And the fact that you are skipping the SageMaker endpoints does not constrain you in using anything else that is available in SageMaker portfolio. I have collected the resources for the presentation that are on the one slide. There are pretty important stuff. It's on the bottom. Those reInvent talks are pretty great, and I can recommend them fully. And yeah, before we will move to the Q&A session, I will be available for questions later on as well under my email that is available on the slide. That's all for I prepared. Thanks for the attention, and let's move to the Q&A.
Thanks a lot, Wojciech. That was a super thorough talk. I hope you share your slides afterwards so that people can go through it. There are 2 questions so maybe if you want to address that and then wrap it up.
Yeah, sure. So Christoph asked, where do you see the benefit of the SageMaker pipelines over AWS step functions? Well, basically, I would go other way around. SageMaker pipelines, in many cases, if you need a simpler pipeline, they are better to do because they are easier to manage and easier to prepare. However, if you need to do something complicated, integrate with a lot of third parties, do a lot of retries and many, for example, very extensive data prep steps, in this case, step functions may be better because the failure modes are handled properly and they are much better than in the SageMaker pipelines. So I would go with the other way around. If you are starting and you want to have a simple pipeline, SageMaker pipelines will be enough. If they are starting to constrain you, I will go to the step functions. I hope this answers your questions, Christoph. And also, Christoph asked again, to me, it feels that SageMaker is attempting a vendor locking by hiding internal workings and tied end-to-end service integration. What's your point on that? Have you ever moved a model pipeline out of SageMaker? Yeah, so this question has two sides. First one, I think that the observation is right. However, I would like to emphasize on one thing. Those elements and those services that I explained to you, most of them are pretty independent. So if you are using one particular service, like, for example, just training or just notebooks or just endpoints, on their own, they are pretty much independent. Yeah, you can move a particular element from one place to another, and you will be able to escape the vendor locking in this place. That being said, if you are using SageMaker Studio, which integrates everything in one place, I think this is a pretty interesting and pretty, this is basically a red flag, because you may have a significant vendor locking by leveraging the SageMaker Studio. This is a risk-based analysis, and this is a trade-off, obviously. Vendor locking is neither good or bad. It should be a decision that you need to have done properly. And regarding your question, have you ever moved a model pipeline out of SageMaker? So model pipeline from SageMaker pipelines, this will be harder to move out, and the same goes with the step functions. However, moving out the models and trained models out of the SageMaker, this is pretty available and pretty doable without any problem. So you can actually train the model on the SageMaker and deploy it somewhere else, and vice versa. You can actually bring your existing model and deploy it on SageMaker without using the training phase. So if you are dealing with those services independently, I think you are safe from the vendor locking perspective.
Okay, I'm afraid we're a bit over time. Thank you so much for your time. Thanks everyone for the questions, and enjoy the rest of the conference.
Thank you very much. Bye-bye. And have a great conference. Cheers.